When a child moves their hands in front of a sunlit wall, the shadows change shape and size in direct response to every motion. To understand why these shapes form, we have to look at how our eyes function. Without the presence of light, human vision cannot perceive any objects in its environment. Light follows a physical law called rectilinear propagation. This is the principle that light always travels in a perfectly straight line. Because a light ray cannot curve around an obstacle or swerve into a corner, it creates a specific geometric footprint of the world around us. This straight-line behavior is the foundational mechanic behind every optical effect we encounter, from the length of a sunset shadow to the view inside a telescope. A glowing filament inside a bulb defines a luminous object. These bodies actively generate their own light energy and emit it outward. Most objects, like the clothes we wear or the furniture in our homes, are non-luminous. They produce zero light of their own. This distinction explains why the moon appears to shine in the night sky. Despite its brilliance, the moon is a dark, non-luminous rock. The moon sits in the path of sunlight, reflecting those straight rays back toward Earth. We are seeing a massive solar reflection rather than a self-illuminated body. Because our world is populated mostly by non-luminous matter, our sight depends on these bounces, light hitting an object and redirecting into our eyes. When light hits a physical object, the straight path of the rays is either maintained, altered, or stopped entirely, depending on the material. Transparent materials, like clear water or glass, allow light rays to pass through completely, keeping their straight trajectories intact. Translucent materials, such as frosted glass, allow light to pass through, but scatter the rays in multiple directions. This makes the objects on the other side appear hazy. Opaque materials, like wood or metal, block light rays immediately. The light cannot pass through, and it cannot detour. This sudden interruption of the light's path creates a dark area behind the object. This region of blocked light is what we perceive as a shadow. A shadow is not a physical object cast onto the ground. It is simply the absence of light hitting a surface because an opaque body was in the way. If you move the light source closer to the object, the angle of the blocked rays widens and the shadow expands. Tilt the object, and the geometry of that blocked light stretches the shape. The existence of these dark, sharp silhouettes provides constant evidence that light is traveling in straight lines rather than bending around the object. When light hits an opaque surface that is perfectly smooth rather than textured, the rays do not just stop, they bounce back in a predictable pattern. This follows the law of reflection, where the angle of the light arriving matches the angle of the light leaving. A flat mirror creates an exact visual copy, but raise your right hand and the reflection raises its left. This front-to-back reversal is lateral inversion. It's why ambulance is printed in reverse, so the mirror flip makes it readable for drivers. We see this reflection as a virtual image. It appears to exist behind the glass, but because no light rays actually pass through the mirror, it cannot be projected onto a screen. This clone in the mirror is the consistent result of straight rays striking a polished plane and bouncing back with perfect geometric symmetry. We can use these physical constraints to build tools. One of the simplest methods involves trapping light inside a dark box through a single pinhole. This creates a real image, a projection formed by light rays that physically strike a surface. Because light travels straight, the ray from the top of the object must angle down to fit through the hole, while the bottom ray angles up. These paths cross at the opening, making the final image appear upside down. A wider hole allows more light in, making the image brighter, but the overlapping rays create a blur. A tiny pinhole narrows the path, resulting in a dim but razor-sharp picture. Periscopes use angled mirrors to move light across obstacles. By bouncing rays twice at 45-degree angles, we can view objects that are not in our direct line of sight. In a kaleidoscope, mirrors are angled to create multiple reflections. These repeating bounces turn a few pieces of colored glass into symmetrical geometric patterns. The physics of light, the straight lines, the blocking, and the bounces, form the invisible structure of our sight. By applying these rules, we can build instruments that extend our vision and redirect the light around us.